Hello everyone, this is Udit with yet another session from TechSpark covering the data engineering questions and answers. Little bit about myself. I have been working in data engineering domain for almost 9 years with various projects and involved in creating data pipelines for several clients. I also train candidates in this field to help them build an interview-ready profile with our comprehensive course covering all the necessary topics of data engineering. In today's session, we're going to talk about one of the Hive's most used feature, that is partitioning. Now, to discuss about partitioning, we must come to know what is the need of partitioning. So, when we deal with big data in the Hadoop cluster, we obviously can expect large volume of files, right? And if we try to read those files and try to analyze them, it would be a cumbersome task, as it would have millions of records. And with a single select star query on top of those tables or files would take a significant amount of time to fetch the result for us. In order to deal with this, one of the most key feature that Hive has is the partitioning. Now, let us look at some of the key points, how partitioning is done or what actually happens underneath and how it helps in query optimization. So Hive organizes tables into partitions for grouping same type of data together based on a column or a partition key. Each table in the Hive can have one or more partition keys to identify a particular partition. So when I have, say, a Hive table with 10 columns, okay, and I know that there is one column that I'll be using more often than not to query the data, putting a filter on that column. Okay, suppose I have the files that is having a date, and each and every day an ingestion is happening. Okay, so each and every batch that has some data that is getting loaded into that table, and date is one of the column that is getting changed for each and every day. So if I use that date column to chunk my data, in that case in the table, each and every day when the data is getting ingested, each and every batch or each and every time a new partition will be created. In that case, whenever the reporting team will try to analyze the data or try to create a report out of the most current data, in that case that team can put a query filter on that date column, and only that block of data will be scanned or getting read for creating the report. Okay, so I will explain this in simpler terms. Now, let us take a look at the other key points. So, using the partitioning feature of Hive that subdivides the data, Hive users can identify the columns which can be used to organize the data. So, I was given an example about the date column and how we can simply chunk the data into smaller blocks using the date column. So, we have to understand what is the column upon which the partitioning should be done, and this is totally on the developers. They need to understand which column can be useful to chunk the data into smaller blocks, and which will help in optimizing the query, because based on the filter query, based on the required result set that we require more frequently, then only we can think of optimizing the query. Okay, so the third point is the analysis can be done only on the relevant subset of the data, resulting in the high improved performance of Hive query. So basically, if I try to query the data on top of that block only, instead of like scanning the whole table, in that case, it's giving me a very less amount of data, not less amount of data, only the required amount of data, and that too in a very reduced timeline. So that helps a lot when I know that my job would be taking a lot of time and I cannot afford to waste that much of time. Right. So in partitioning method, all the table data is divided into multiple partitions. Each partition corresponds to a specific value of partition column. It is kept as a subrecord inside the tables record present in the HDFS. So as I have already mentioned this several times, Hive is just an abstraction on top of the data that is residing in HDFS. Hive is not a physical database. It doesn't have actual tables where we store the data, but we are storing the data in HDFS at the end of the day. I mean, the data will be fetched from the data nodes of the data lake. And what Hive is actually doing is just imparting a schema on top of the data that is residing in Hadoop. So when we create smaller chunks of data using the partitioning feature, in that case, what happens under the hood in HDFS, there will be folders. There will be folders pointing to that each and every chunk or each and every block. So whenever I'm trying to query that required amount of subset of data, in that case, my Hive query is pointing to that folder only and not the all the folders or to all the data. All right. So that is that. So that's the way Hive significantly optimizes the query performance when partitioning is enabled over there. From the Hadoop side, also, it will only read the required folders and not all of it. All right, so the last point is appropriate partition of the table is queried which contains the query value. This decreases the IO time required by the query. Now, IO time means the input output throughput. Input output throughput, as in when we do a select star query on any table, so that table will be reading from the data that is lying in the HDFS. Right. So there will be a time of communication, like there will be a gap that my queries run, and then the Hive compiler will analyze and understand the query, get the metadata information and everything, and then it will fetch the data, the actual data from the data node. So there is this time, from the Hive connection to the Hadoop. So that's the input output throughput. So uh, so when there is a huge table and my select star query is scanning the whole data from each and every folder in the Hadoop, in that case the throughput time gets uh, increased like tenfold. Okay, but if I want my query to run faster and I know that I don't need the whole data, there's only some amount of required amount of data that I want to deal with, in that case Hive will, or my select star query will simply get into that folder, that particular folder that I require, and only from there it will try and fetch the result. So this is how the Hive partitioning works. Now let me just simplify this in layman terms. So there is this image on the right side, right? Now if you see, there's a 10 billion record table over here, and that is being chunked into different folders or different partitions. Okay, so one partition is of 2012, the other one is 2013, 14. So these are year data. That means all the data that is corresponding to year 2012 will be residing into this block. Similarly, for 2013 data will be residing in this block. And if I try to understand the row count, so for 2012 it has like 1 billion of data. For 2013 it has 2 billion of data, and so on. For 15 it is 3 billion of data. So now you see that this 10 billion chunk has been reduced for each and every year, like 1 billion, 2 billion, 2 and 3 billion, so on. So if you add this up, it is 10 billion. Okay. Now, me being a BI reporter, or me being someone who's querying the data more often than not, and I'm using the year clause in my filter, and I'm only suppose like each and every year I'm reading the data. In that case, what happens in the year 2012, if I try to read only this data, only 1 billion of record I'll be scanning. Okay, now obviously in the year 2012, the 2013, 14, 15 data won't be present, right? But if I consider this one, 2015, so 2015 data, if I try to read, in that case, I have to scan 14, 13, and 12. So basically now I have 10 billion of data. But the thing is, I only want to analyze, or I am only, and I only want to deal with the 2015 data. That is the 3 billion records. So what is the need of scanning all the rows that is in the 10 billion record table? So in that case, I can only fetch out this 3 billion out of 2015, and my job is done. So that's where Hive partition comes into play, and it helps us fetching the result set in a very less amount of time. Okay, so if I try to do a select star query where year equals to 2015, in that case, I'll be only scanning this 3 billion records, right? This other 1, 2 plus 2, 4 plus 1, 5, this 5 billion record won't be scanned at all. Okay, now there is another thing with the Hive partition is that not only I can put into one column, but I can put the partition column as multiple column. In that case, what will happen that for each and every year, if I put month as well in the partition column, in that case that will be segmented furthermore. Meaning, suppose if you take this 2013 data, so each and every month has like 10 million, 10 million. Okay, this one has 35 million. Basically, now if I put a filter where year equals to 2013 and month equals to May, in that case, I am only reading this 10 million data. Now, this 2 billion is also chunked in 10 billion, 10 billion, 35 million. And I believe there are other more data that is not being shown here, just like over here 10 billion. And if you total sum it up, it is around 5 plus 3, 8. So there would be 2 billion other records as well. But what I'm trying to make you understand over here is that uh, putting the partition column as year and month, and my query is just trying to read out the 2013 May data. I'll be scanning only the 10 million rows, not the full 10 billion rows. So you can understand like how much time it is getting reduced and how fast my query will be running, right? So this is one special feature of Hive which is being used in all project work. I mean, each and every project you see Hive is being used, partition has to be there. I mean, it's been like widely accepted, and that is the reason it's one of the most talked about feature of Hive in terms of query performance. Okay, now let me show you one example of Hive table where the data is partition or the table is partition, and how it actually looks under the hood when I try to see the same data in Hadoop cluster. I was talking about the folder structure and whatnot. Okay, so now I'm in my data lake, that is the Hadoop cluster, and I need to connect to my Hive console. So in order to do that, just write Hive and press enter and set for a minute. So the Hive session ID is generated. That means my Hive session is up and running. And yeah, my console is also now started. So I'm going to use the data hub database that I had created earlier for myself. Now let me look at the tables that are present over here. So currently I have this social circle table, which is not a partition table. To kind of confirm that, let me just take a look at the table and see how the structure looks. Right. So these are the schema. That is the serial number, name, age, number of friends. And I don't see any partition clause over here. This is the location where my data resides. So this is just a normal Hive table. I don't have anything to do with this. Okay. So now I know there is some partition data that is residing in the Hadoop folder in one of the in one of my folders. So I will try to create a partition table on top of that, and then I will show you how it actually works. All right, so I have my query ready. So I'm gonna paste it over here. Now look at the query. So this is the external table I'm creating because the data is residing in one of the path or directory that is not pointing to the Hive metastore. And if you remember from the session of internal and the internal table will own the metadata as well as the actual data, whereas for external table, the actual data will be residing somewhere other than metastore. Only the schema or the metadata information will be kept in the metastore or the Hive warehouse metadata directory. Okay, now if you see the second line, that is partitioned by age category. Now this is one column that is part of the data, part of the file that is in the Hadoop data lake, and I'm using this column as the partition key. Right. Now, if you look at the create external table command, and if you look at the schema, the column names that have been mentioned in the definition, you won't see this column that is being used for the partition. The reason being is that whatever the data I want to partition by, that won't be part of the actual schema, or that won't be part of the table definition when I am putting all the column names in tandem with the data types. So this will be a separate way to deal with, and the reason why we don't put it in as part of the main table definition but in a separate partition by clause, you will come to understand when I show you the Hadoop file structure. Okay, so third line is stored as ORC. Now I have also said that there would be different file formats, some as structured, some as unstructured, and ORC is one of them. Okay, so ORC is a binary format file which is not human readable. So if you try to browse the file, you won't understand a thing. All right. But Hive can deal with ORC files. If you try to create a schema on top of ORC file, that works in Hive. And ultimately, the location that I'm putting over here is this one. So my table has been created. Now, table is created. Let me try to do a select star query and see what it fetches for me. I'm going to put a limit over here. I think there's a typo in the select. So it returns nothing. Why? Is it because the data is not present over here? Or is it because there is something wrong with the table creation? To be very honest, there's nothing wrong with the data that is residing over here, and also there's nothing wrong with the table creation. Had there been any issue with the table creation or the definition of the partition table, in that case it would have failed there. But the table was created, and in fact the table is there. The table is created. So if I do a DESC formatted and put the table name over here. Okay, so my table is created, right? I can see the schema over here. And if you see, if you try to compare with the previous DSC formatted query, now there is the partition information, okay? And over here, the H category column, which I just put in my partition key clause, it is being highlighted over here. Now, if I have the previous one, so this is the previous one, which is for a normal table, social circle. And over here, you don't see any partition information as such. So that's where we can confirm that this table is not partitioned. But if I come to the later one, there is a partition information that is present. So that means it has been fetched in my metadata that this table is partitioned, and then the partition key or the column is the H category. Now, so the table is created, partition key is there. So what is wrong? Why my data is not being highlighted? So there is one thing you need to know, that when I'm creating a partition table, and I'm just creating an external table on top of the data residing in Hadoop data lake. The Hive metastore cannot immediately fetch the data that is in the Hadoop data lake. So that is the reason Hive metastore not able to retrieve the data from the data node, from the data lake into my Hive console. So in order to make it work, there is one command that I need to run, and then only my selector query would work. Now that command is msck repair table, then table name. So if I do that, you'll see my partitions are getting added. Okay, so these are the three column values through which the partitions have been created. The H category was the partition key, right? So H category has three different values. One is middle aged, the second one is youth, third one is old. I think I had created this partition folder based on the age of each and every person. So if someone is like less than 25, then he falls into the youth category. Someone say from 35 to 50 or 60, then that's middle aged, and the rest are old. So that's how I created that column. uh, Okay, so now the thing is, my partitions have been added, and that's how Hive Metastore now can understand. So there are three different key columns, and if you look at this slide, and if you look at this picture, year equals to 2012. Over here, if I try to sync up this picture with my Hive console, whatever is being shown over here, in that case you can understand year equals to 2012 would be one partition, year equals to 2030 would be another partition, and so on. So similarly, age category is my partition key instead of year, and age category, the value for each and every age category is middle-aged, youth, and old. Likewise over here, for each and every year the value was 2012, 23, 2014, and so on. Okay, so now the partitions have been added to the metastore. If I try to do a select star query now, probably I can see some data. Yes, I can. I can see the data over here. Yeah, the header is not printed. Let me just tweak that configuration. Okay, so now I have my header visible as well. So if you see the last one, that is the age category column, and that is being highlighted over here for middle-aged and there would be youth and old as well. So this is how a partition column, so partition table looks like. And so if I want to see that what are the different age category count, I mean for each and every age category, what is the count? Let me just run a group by query. Select category count one as say age count from the table name, group by age category. So let me run this one. All right, now you see the moment I do a query on the group by column, so it is now running a MapReduce job. All right. So I told you, right, Hive underneath it actually works on the MapReduce job. And though the MapReduce have been obsolete now, the Hive still uses this engine. There are different engines such as Taze or Spark, but we'll talk about that in later session. So for the moment, you can see this for each and every age category. The counts are somewhat like the middle-aged are 114, old is 113, and youth is 74. So basically, there are 114 rows or 114, 114 row counts are there for middle-aged category, and there's 113 data, 113 count row data for old, and for youth it is 74. So. So now it is understandable for us how Hive actually is reading the partition columns and mapping to the data that is inside the HDFS. Now I'm going to show you that how the data is underlying in the HDFS actually, instead of, I mean, if we talk about the folder structure, how it looks like and how Hive is kind of mapping to its different partitions. So I'm going to get out of the Hive console by pressing Control Z. Now let me try to list out the directories inside that folder. So this is my actual table folder, even though my table name is social circle underscore part, but from the location it's reading, it's the folder name is social circle. Okay, so a very important thing to notice over here, we have different folders. Okay, just forget about this success. It will always be there. A default one means the data has been loaded into Hadoop cluster. So if you try to use Spark or something like that to read the data, sorry, to write the data, in that case, this success folder comes up. So I used Spark previously to write the data into this folder. So that is why this success folder is showing up. Even if you delete this one, it won't make much of a difference. So this is just out of scope for the moment. Now coming to the folder structure. So inside social circle, so that is the root folder or the parent folder, which is being pointed by the Hive table. Now you see the age category equals to middle aged, age category equals to old, age category equals to youth. So three different folders, and this folder naming convention has been so that the partition key equals to the column value. That's how it is. So when I created the table on top of the social circle location inside the Hadoop, so at that point, Hive doesn't know. I mean, inside the table, it doesn't find any ORC table because I put the file format as ORC and the location as social circle slash uday slash social circle. So Hive was supposed to find some ORC files inside the social circle folder, but Hive couldn't find that. So that's why at first I wasn't able to fetch any data from for me when I ran the select star query. But with that command, that is the MSC repair table, which means I am making Hive to understand that there is metadata update is required because the table is partitioned. So immediately Hive just looks into the folder structure and Hive gets it right. Okay, so there is a partition key age category which is having with three different values: middle-aged, old, and youth. And after then, when I ran the select star query, then I could see my result. So that's how basically Hive works, with the partition phenomena. That's how it actually helps in query optimization. Now, one key thing to note over here, I didn't run in select star with the filter clause, where clause. Now, if I had used that where clause in my query, suppose say where age category only equals to middle age, in that case, I will simply go into this folder only. Age category is equal to middle aged, and then I will try to scan the data from this folder only. Now, if I go into one of these folders and try to see how the data looks like, so inside this, now this is the actual ORC file that Hive is supposed to read from. Okay, this is where the data is being contained, right? If I put an age category equals to middle aged in my Hive query, in that case, Hive will simply read only this file only and not the files from the other two folders. Right. So you can understand how significantly Hive can reduce the query, the tenure of how long the query would be running by simply partitioning the data. So that's all from this session and talking about Hive partition. You must be wondering in the this is my local system, and I created this Hadoop data lake cluster inside my local, which is not an easy task. And I can run any Hadoop command or any Hive query over here. So you must be wondering, how do I set up all this Hadoop and HDFS? Just reach out to us, reach out to TechSpock, and we will help you and guide you with our comprehensive course. We cover all the necessary tools in our data engineering course, such as Spark, Hadoop, Hive, AWS, with hands-on coding and real-world project. So we will help you in not only get tech savvy on all these roles, but we will also help you in building the resume, and also will help you in assisting getting the actual job and be and make your profile interview ready. So that's all from today's session. See you on the next one. Till then, bye bye.
Contact us for the free job assistance. We will help you to get the IT job. Please like, subscribe, and share the channel for more regular updates from TechSpoke.